Hi, good afternoon. This is Drew Borders of Blaser Swisslube. And today I would like to introduce Jos Christoffel, who is the head engineer on our MQL division of Blaser, MQL being Minimum Quantity Lubrication. He's here to talk today about some of the advantages and some of the pitfalls and some of the pluses and minuses of MQL. And then, of course, have time to have an open discussion with you concerning any of your questions, an introduction into what MQL is, some of the different styles of MQL, and then certainly, some of the advantages that we have. So with that being said, I'd like to turn it over to Jos. Jos is a Swiss national who lives in outside of Hasley-Ruchsau, or in Hasley-Ruchsau, where our home office is, and it's a pleasure to have the time and effort from the NTMA to introduce Jos. So Jos, with that, I ask you to take it over.
Drew, thank you very much. I would like to welcome everybody to my presentation, to show my face, and I'll switch to presentation mode now that we really have a good connection here from Switzerland. So I would like to talk with you about MQL, Minimum Quantity Lubrication, and how to boost your productivity with Blaser MQL. To the content of this presentation, first I would like to mention the MQL basics. So what to look for, as Drew said, to really identify the pitfalls. In a second step, I would like to talk about the MQL technology a bit more detailed. Then the third step is going to be the importance of process engineering being done for MQL processes. And the fourth point is going to be the success stories. So what is minimum quantity lubrication? As you see in the picture taken in our technology center in Hasley-Ruchsau, minimum quantity lubrication is an aerosol being used as cutting fluid. So you have a mixture of oil and air being brought into the cutting area. It is mainly used for high volume applications and productive processes. So you really need the size of the series to make MQL work out for you. It is a pure loss lubrication, so the oil you bring into the process is used up. And we're talking about oil quantities are in between 10 and 100 milliliters per hour with a maximum of 500 milliliters. But this is not very often used, and an air pressure in between, the average is between 4 and 10 bar. Being able to go up.
Interrupt one sec, Jos. To those who aren't familiar with bar, it's about 18 psi per bar. So you can do the calculations yourself on what that means. So I'm not sure everyone's aware of that. So go ahead, Jos. Thanks.
Thank you very much, Drew. So you have, because you only have a little bit of oil and air in the process, you are not able to really get the heat out of the process. So very essential is lubrication, that less heat is produced, and of being able to cut away the heat in a process. And the way this is done, I'm going to talk on the next slide. One of the key elements is really increasing the parameters. So the heat creation in a cutting process is the friction between the tool and the workpiece, and the deformation of the chips. And there, the lubrication is really essential to be able to creating less heat in a process. And the way to cutting away the heat is by optimizing cutting speeds, feeds, and engagement, that the heat is transported away with the chips. Kind of easy said, but relatively hard to do. But the theory behind it is the speed of material removal must be higher than the speed of the heat influence. And if you achieve this, then about 70% of the heat can be carried away with the chips. So if you're going productive and if you are cutting faster and get the heat into the chips, this is very, very helpful for processes, for tool life, etc., everything. So how do you achieve cutting away the heat in a specific process? One main goal is to reduce the contact time between the tool and the workpiece. And the way to do that is to increase cutting speeds, increase the feed rates, and reduce AP and AE. Everything mixed up, but one very essential point is the reduction of friction by using high-performing oils. This is also very important. So you see there are a lot of variables that can influence the process. And in general, this leads over to the requirements of an MQL process. You have a high complexity in the MQL processes, and the solutions are not at all plug and play. This is what I mentioned in the beginning, that the process engineering becomes a very essential part of minimum quantity lubrication. So you see the variables: machine, MQL device, the tool is very important, the MQL oil, and also the parameters, and everything has to be set right to get a process working. And to be able to, for us to mill a balloon in our technology center, there is also very nice video of this process done with MQL. But how is this possible? It's only the right combination of all these influencing factors that enable an optimal process with MQL. And I always identify the machine as one, or probably the biggest key element in a process, because if a machine, it is very difficult to retrofit the machine with MQL, and if the spindle construction, for example, isn't suitable for MQL, then it's nearly impossible to implement the process on this machine. Another very important factor is the tool, or in general, to just make sure that the aerosol is brought to the cutting area very continuous, and that you don't have a big bandwidth of different droplet sizes. So to have many big and small droplets, here we were high-speed filming two different tools to identify or to analyze the aerosol transport. And on the right-hand side, you see there are big drops. There is a inconsistent aerosol transport. So in between, you are cutting dry. And on the left-hand side, you see, I have to say, more or less continuous aerosol transport, but at least the cutting area is always covered with lubricant. So you really have a consistent lubrication of the cutting area. probably the key element of MQL is the business process engineering, to really look at the process as a whole and also identify what brings the most value for a customer. And my personal approach is always to look at, if say you have a defined process and then you look at the tool, there you have a very big influence on a process with an existing machine and existing MQL device, and also look at the MQL oil. And there is no right or wrong tool or MQL oil. It's always the combination of the two defined over the parameters that make a process work. So the tool, for example, cooling construction is very essential. What geometry you have, what coatings are used. But the aerosol, the cooling channels, the aerosol transport can be really a key issue. So this can kill a whole process if the cooling channels are not constructed in the right way, and the machine defines what parameters can be used. And the MQL device is for example, the oil amount and the air amount in a process, and MQL oil defines spraying behavior, residues, and very important cutting performance. And this playing together defines the productivity. So how productive can you produce? Can you machine your parts? And also identify where you are able to reduce costs. The fields of application for the MQL are the main market, you can say, are the two segments, aerospace and automotive, where there are very high volumes produced. In the aerospace, it's mainly the structural parts, aluminum processes, various processes and materials, say mainly aluminum, steel, and cast iron. There are a few others I will come to in the next slide. Here you see the different materials being processed with MQL, and the big part is aluminum, second one is steel, and third one is cast iron. And what is coming more and more are high temperature resistant materials, but they are even more complex than just a standard MQL process. So that it's getting really difficult and needing a close collaboration between the various companies of tool builders, machine tool builders, MQL device builders, and we as a cooling producer, together with the customer, to define these processes. So what are the advantages and disadvantages of using MQL? One main thing of what was in the 90s when the MQL was being developed in the German industry, metalworking industry, was mainly to get rid of the coolant if it was possible, and to increasing the productivity. So in the 1990s, over a span of 10 years with developing tools and machines and everything, he was able to increase the productivity by a factor 10, so 10 times as fast as in the beginning. But this was not only MQL, this was a development of new tools, of carbides and everything being brought into this equation. There is a possibility that with MQL there are going to be big cost savings for coolant peripherals, monitoring, maintaining and disposing the coolant. So you don't need a big central system, for example. You don't need to monitor your coolant, top up your coolant and get rid of your coolant after it is used, because the MQL is a loss lubrication. You just bring in as much lubricant as is needed in the process. There are lower costs for cleaning and drying the chips because you bring in less coolant. There is also less work to take this coolant off the workpieces. It also helps that the chips have a higher worth, a higher value for the customers, and sometimes cleaning of the workpieces is at least reduced or can be completely eliminated. This depends a lot on what industry we are talking about. So just saying the workpieces, the cleaning of workpieces is eliminated is not always possible. There's much less built-up edge behavior, especially in aluminum machining. But it also depends a lot on tool construction and everything, but increasing process reliability, tool life, surface quality. So you have the main values are cleaning, less cleaning, higher productivity, higher value for recycling, and increasing process values or reducing costs. The disadvantages of the MQL, one of them is depending on the constellation with the customer. There are very high investments needed for retrofitting the machine or needing a new machine for being able to work with MQL. Tool costs can be higher because of the construction of the tools. And there is a lot of effort needed to get the processes work out. So a lot of engineering of workpiece, machine parameters, tool lubrication and everything. So this takes up a lot of time, and that's also why MQL is mainly seen in the large scale production. So that was it with the MQL basics. Now we come over to the MQL technology to go more into detail of the technology itself. First of all, I would like to talk about the aerosol delivery. And then we'll come to the technology of the MQL devices, and then also what the requirements there are for tool holding and tools for the MQL. The aerosol can be delivered internally or externally. If you go externally, it's easier to upgrade machines. The lower investments for MQL devices, for example. So these are the easier MQL devices, and they are cheaper, the internal ones, but they are very limited if you have a certain bandwidth of processes of tools of diameters. For example, if you have different diameters and different length of tools, then it's very difficult to be able to make an external MQL aerosol delivery. And of course, there is always a risk of collision if you go externally to the tool. But for example, for sawing applications, external delivery is the standard. So, for example, an internal aerosol delivery is suitable for all processes if the tools are optimized. And the oil can be really brought into the cutting area. So this is especially for deep hole drilling, for example, the internal delivery with the right tools is key to make the process right. But also the air flow through the tool helps with the chip transport. I mean, with the coolant, one of the jobs of a coolant is to transport the chops, and if you don't have the coolant that transports them, the air takes it over. But the disadvantage of internal is that you need to look at the spindles, that you need spindles that are fit to take MQL, and to also look at the tool holders and tools very much in detail. So I'm going to talk about the two different philosophies of the MQL devices. This is the one-channel and the two-channel technology. With the one-channel technology, the aerosol is produced within the MQL device and then transported through a tube, through the spindle, through the tool holder and the tool. So with one channel and the two-channel technology, the oil and the air are transported separately through the spindle and the aerosol is mixed in the tool holder here. Then brought into the cutting area. And here you see the different MQL devices, or the different, it's not all of them, just some of them that you see. One channel technology is with the internal delivery is much more common, but with the two-channel technology, the external MQL delivery is like the standard. And if Belomatic two-channel, if you see a Belomatic MQL device that goes internally, then chances are very high that it is a Belomatic two channels. They're coming. Oops. They're increasing the one-channel technology also, but until 2 years ago, the two-channel technology was the big player with Belomatic. So the comparison of one channel and two channel is mainly that with the two channel system you have bigger droplets and that you can also bring in a higher oil amount into a process. Because the oil quantity is not depending on an airflow rate, because with one channel technology the saturation defines how much oil in terms of milliliters per hour can be transported into the cutting area, and with the two channel device this is much higher. So because you have two channels, you can bring in more oil here with the oil lens, and then the air just rips the oil droplets with them. You don't really have a saturation of oil within the air, but you have a airflow that rips oil droplets with it. And that's one of the reasons why you have bigger droplets.
You know, it's one comment that I learned today from the Belomatic group at Eastech is that the two-channel system is a lot easier to measure through a calibration kit, the amount of oil that gets to the tool. And that's a big advantage also of the two-channel system.
Yeah, I think the main difficulty with one channel MQL devices is that you cannot really set the MQL device to deliver a certain amount of oil. With the two channel device you can say give me 100 milliliters per hour with such an airflow, so you can define the oil and the airflow. And with the one channel device you just make an aerosol that has a certain amount of oil in it, so it's very difficult to set up also. And also the directness of the two-channel technology. Here you have the within the tool holder, so if you change any setting within the MQL device, then it's very, very quick to respond until you are in the cutting area. And with the one-channel device, you first have to get from the MQL device up to the cutting area. But thank you, Drew, for the input. So what is essential if you go internal feeding to look at the tool and the tool holders in detail? So it's very, here you see a tool holders, the complexity of the tool holders, of the coolant supply units that You need a length adjustment screw, and you also need to construct the tool shanks in a certain way to be able to deliver the aerosol through the tool. And here you see one of our tools. We even had to regrind the tools to have the right shank dimension and everything, to be that the aerosol is really only has the possibility to go through the cooling channels. So you have to seal everything here, that the aerosol can only go through the supply unit, through the length adjustment screw, and into the cooling channels of the tool. And with the two-channel system, the cooling unit needs to separate the oil and the air, and it is a bit more complex to get these. But with certain tool companies, these are standard, how do you say, articles, products they have, and you can just order them. But it's very important to just look at the tools, and the tool holding is also one very essential key. So tools must be constructed to secure a continuous aerosol transport. This is pretty easy, but the cooling channels, the definition or the construction of the tool cooling channels, the surface quality of the cooling channels, the sizes of the cooling channels are very important. And here you see 3 examples of cooling channels. And first one is not suited, is not good for being used with MQL, because you have, here you see you have certain cavities within the tool holders, and here the air and the oil is separated. So you produce bigger droplets, and you produce an inconsistent aerosol transport. In general, the key element is to look at the surface of the inlet of a tool and to look at the surface of an outlet, and the surface area of the outlet must be smaller than the surface area of the inlet. So with cavities, this is not suited. If you have 90 degrees angles of the cooling channels, this is, maybe it can be used, but it's much more difficult to deliver the aerosol to where it's needed, compared to the best suited option where you have a slow changing of angles of the aerosol for the aerosol of the cooling channels. So this delivers the aerosol the best way. So one key element for me to be able to make an MQL project is to have good partners on board, to really work out processes together with partners, because the tooling guys, they are the experts on the tools, we are the experts on the oil or the aerosol production. The device builders are very important, and also machine tool builders. So this enables us to be able to engineer productive MQL processes. With the machine tool builder Startup and Grob, we have strong partnerships with the tool builders Walter, Güring and Mappal. With the MQL device builders Pilomatic, SKF Vogel, Unist, HBM Technology and Knoll. We're also working with others, but these are like the main players that we are working together. And for us to be able to do process engineering for customers, we do have a machine in our technology center where we are engineering processes together with our partners for our customers. And the machine allows us to make direct comparison of processes of MQL with emulsions or with neat oils. And for us to be able to quantify an MQL process, we had to develop our own test possibilities in, let's say, the last 10 years. So with a LAMP test, we were able to work out the test possibilities to really visualize the aerosol being produced. As you have seen in the introduction photo, where you see the aerosol, and we developed a filter test to really measure the amount of oil that is brought to the cutting area, so that the amount of oil that comes out of the tool, where we can test different tools from customers also, or from tooling partners. Then we developed the spraying test. I have to say the spraying test, it was developed by Mercedes-Benz, but we developed a measuring unit to be able to quantify this spraying test. And we also have the possibilities to monitor health and safety aspects with the dust track. We're able to do thermal camera filming, identify or analyze the process temperatures, and with the high-speed camera we are able to identify the chip flow. For example, once we are doing a project 3mm 30 times D, drilling in aluminum, and there it was very important to be able to look at the chips and how the chip flow worked out. So then we come to the success stories that we were able to work out for our customers, and one very nice example was a producer of cast aluminum workpieces for an automotive company working with FA2, and he was able to eliminate his cleaning process completely. So with a very strong performing MQL oil, he was able to reduce the oil amount needed, and that way he could eliminate his cleaning. The second one is machining ALSI7 with Vascomil MQL FA2. So we were able to increase the metal removal rate, go to 3 times as fast. In the beginning, you will see a video right afterwards. And also a very nice example is the machining of wing ribs made from 7075, 7050, and 2050 together with this. There we were working with Walter and Starok to increase this process. And there was especially on 2050, this was a very sticky and difficult to machine material, where we were able to increase the tool life by 100%. So I've done a lot of talking. Here you see an example drilling ALSI7 with MQL, and as you see, the temperature is cut away with the chips. It is not really in the workpiece. There isn't a high temperature. And in the tool, we were measuring the temperature, and you will see right on the next slide what the influence of the oil in an MQL process has. So product 1, we have an average of 100 degrees Celsius, and with another product, exactly the same process, we were able to reduce the temperature by more than 20 degrees. Celsius. So this again is a chance for the customers to then increase the productivity again, or have a higher tool life, or there are several approaches of creating value. Next one is a friction test we developed in-house, and here you see again the influence of the lubricant on a process, exactly the same process with 3 different oils. On the left-hand side, you have a very rough surface, a lot of build-up. On the right-hand side, you have a very fine surface and almost no build-up. And you see the friction test temperatures in the friction tests speak for themselves also. Now I was talking a lot of cutting away the heat, and to give you a little example, I would like to show you here we were milling stainless steel with MQL. And here is very good to see how the heat is cut away with the chips. As you see on the thermal imaging, the workpiece was cool, so you could, right after the milling process, I was able to touch the workpiece with my hand. It was cool. Like room temperature 20 degrees, and we were analyzing the temperature in the tool again. We developed a baseline dry cutting to have, you see the green curve, and then with the red curve we were introducing our oil to the process, and the black curve is where we increased the productivity. We were cutting 4 times as fast with the black curve than with the red curve. And over here we have with the black 4 times as fast, we have just a slightly higher temperature, but the temperature increase is less than with the red, than with the slower process. So what are the fundamentals of a successful implementing MQL technology? It's really the big size, high volume machining processes, and to optimize a complete process by choosing a suitable combination tool, MQL oil and parameters, and to set everything right that it works together to increase productivity. From our side, it's really where we are able to help is with the high performing MQL oils. We're able to reduce the friction and help the customers increase productivity. And the key to cutting away the heat is to be able to increase the productivity. Here we come to the last video where you see the success story I mentioned before. We were able to make the process 3 times as fast. As in the start, you see with 650 meters per minute and feet per tooth. Maybe Drew, you have to translate the dimensions afterwards. We were just slightly below 1 inch and just testing out the process to see the influence.
We're moving to the metric system 1 inch at a time.
Yeah. So you see on the top, this was product X, the reference product from the customer, and we were able, with our liquid tool, we were able to increase the productivity. And just to show you what happened when we did the same with the other oil that was used before. You see that now in the top row. So there really wasn't any any tool life at all. And with the higher parameters, we were able there. We didn't have any tool break, and we were able to just mill the material down. Yeah. So we have to see that we don't overstretch the presentation. So I'll just stop the video now. It doesn't get more. Give you any more information. So based on this, on our know-how and on our engineering, and in cooperation with our partners, we are able to help you boost the productivity of your MQL processes.
And ballooning is also our other passion.
Thank you, Drew. So
well,
that was.
Linda, oh, go ahead, Jos.
No, that was it from my side.
We leave this up to any questions for Jos. Any issues that you wish to discuss? A lot of information here to digest. I want to, first of all, thank you, Jos. A very good presentation that I think is a very well-rounded presentation to what MQL is all about, and how you know, MQL, whether it's Blaser or other companies or what have you, can help you. Certainly, you know, there may be production pieces in some of our members that could benefit from this. Looking at some investment to really look at production parts, etc. And I don't know, at this, Linda, I open this up for any questions that any of our NTMA members may have.
Yes, Drew and Jos, I do not see any questions in the question box at this time. And I also would like to thank you, Jos, for a great presentation.
Yeah, here.
Hopefully I didn't lose too much into my details in the MQL world.
No, thank you very much. We sure appreciate your time today.
Thank you very much.
Thank you for everyone for joining us today. Have a great afternoon.
By the way, Linda, Jos in Swiss German means MQL. I don't know if you knew that.
Oh. And on that note, goodbye.
Linda, I look forward to seeing you soon, huh?
Yes, I will call you after, okay?
Okay, great. Thanks.
Okay,
bye.
thanks.
Thank you very much. Bye-bye.
Jos, thanks again. Great presentation, brother.
Thank you. Have a nice evening.
You too. Bye.